Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate an empirical formula. So let's jump right in and take a look at an example problem. In this example it says a 283.9 gram sample of unknown composition was carefully analyzed and found to consist of 49.8 grams of sodium, 113.6 grams of chromium, and 121.4 grams of oxygen. We need to determine the empirical formula of the unknown compound. So we have a compound here, and all we know about the compound are the masses of the individual elements that make up this compound. So we have a compound that's 49.8 grams of sodium, 113.6 grams of chromium, and 121.4 grams of oxygen, and we need to determine the empirical formula of the unknown compound. So how can we do this? Well, whenever we're asked to determine the empirical formula, that's going to be the formula in which the subscripts are expressed in the simplest whole number ratio. We have to first convert the grams of each element to moles. So in our very first step, in step one, what we're going to do is we're going to convert the masses to moles. So let's go ahead and do this. In this problem here, it says that we have 49.8 grams of sodium, 49.8 grams of sodium. It says that we have 113.6 grams of chromium, and it says that we have 121.4 grams of oxygen. And so we need to convert each one of these to moles. So we're going to divide each one of these by their molar masses that we can find on the periodic table of elements. So we know that 1 mole of sodium, if we look on the periodic table of elements, just like the one that popped up in front of you, is 22.99 grams of sodium. We know that 1 mole of chromium, if we take a look on the periodic table that just popped up, is 52.00 grams of chromium. And we know that 1 mole of oxygen, if we look on that same periodic table that just popped up, is 16.00 grams of oxygen. So now all we need to do is take 49.8 divided by 22.99, and we're going to end up with 2.166 moles of sodium. And in this step right here, when we're figuring out the number of moles, I like to go ahead and keep 3 decimal places, so that way our number in the end here, at the end of our calculation, isn't too far away from where it needs to be. Alright, so here we go. Let's figure out the number of moles of chromium. We have 113.6 divided by 52.00, and we end up with 2.185 moles of chromium. And if we take a look right here, we're going to take 121.4 and we're going to divide that by 16.00, and we end up with 7.588 moles of oxygen. So now that we've converted to moles, in step 2, what we have to do is we have to divide each one of these amount of moles here by the lowest amount of moles that are present. So if we take a look, we can see that the fewest amount of moles is 2.166. So in step 2, what we're going to do here is we are going to divide by the lowest amount of moles. So we're going to divide by the lowest amount of moles. So let's take a look. What's the lowest amount? We just got done saying that 2.166 is our lowest amount of moles. So we're going to divide all of these by 2.166. 2.166. We'll divide this by 2.166, and we're going to end up dividing this by 2.166. So This ends up becoming 1. This also ends up becoming something very, very close to 1. And this divided by this, or 7.588, divided by 2.166 is 3.5. So, what are these values right here? What are these values that we get right here? Well, these are going to be the subscripts. These values are going to be the subscripts of the individual elements in this compound. So these are the subscripts for the individual elements that make up this compound. However, we see an issue here. We can't have a subscript that has a decimal in it. So how do we get rid of this decimal? No, we can't just round this up to 4. The way that we get rid of a decimal, or a number that has a decimal that reads 0.5, is to multiply all of these subscripts by 2. So if we multiply all of these subscripts by 2, multiply this by 2 and multiply this by 2, we can see right here that by multiplying this number right here by 2, we're going to end up with a whole number. This becomes a 2 and this becomes a 2 right here. So in this step right here where you're figuring out the subscripts of your empirical formula, if you have something that ends in 0.5, go ahead and multiply that by 2. If this were to end in 0.33, you'd multiply all the subscripts by 3. And if this were to end in 0.25, you'd multiply all these subscripts here by 4. So what is the empirical formula of this compound? Well, let's take a look. We have Na2, right? We have Na2. We have Cr2, and we have O7. O7. So it looks like our empirical formula here is going to be sodium dichromate. Alright, if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and feel free to leave any comments or questions in the comment section down below, and I really hope you guys found this helpful.